This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
For decades, physicists have been trying to build a unified theory of everything. The problem? They've been building a skyscraper on a foundation of what is, essentially, mathematical quicksand. Their models were brilliant, sure, but they all had a fundamental weakness. Today, we're looking at the proposed solution, the Pasev layer closure, a completely new approach to building a rock-solid foundation for reality itself. So, what was the real issue here? Well, the core problem was that these older models could never really be finished. Think of it like a set of Russian nesting dolls that just goes on forever. You keep opening them, but you never ever hit that final solid doll in the center. In the world of mathematics, this is a fatal flaw. It's called non-terminating structural collapse, and it's a recipe for the entire theory to just fall apart. You see, this infinite nesting doll problem is what's known as an infinite descending chain. It's a structure with no bottom, no final piece to rest on. And as you can see on the left, that leads to total collapse. What was desperately needed is what you see on the right, a well-founded structure, a stable tower with an absolutely guaranteed solid base.
So how do you actually fix this? A researcher named Pasev came up with a brilliant solution called a Well-Founded Ordinal Base. Now don't worry about the complex name. The idea behind it is actually incredibly simple. It's like writing a new unbreakable rule into the math that just says, nope, there must be a smallest fundamental building block. It guarantees that there's a final nesting doll. This one powerful idea mathematically slams the door on that infinite collapse, creating the secure foundation to build upon.
Okay, so now that we have that solid ground to stand on, we can finally start building. This next piece of the puzzle is called an ordinal fiber bundle. Just imagine that each one of those fundamental blocks on our new base has a perfectly straight, perfectly rigid pole sticking straight up from it. These are the fibers. What you get is a structure that is unbelievably strong and stable. No matter how you twist it or change it, those individual fibers stay locked in and totally secure. And this is where it gets absolutely amazing. Because once you construct this perfect mathematical structure, the laws of physics seem to just emerge from it, all on their own. Abstract math on this grid translates directly into real-world forces, things like gauge connections, field strength, even the very fabric of space-time itself. They all just appear naturally from the geometry. The math isn't just describing reality anymore. It's starting to look like it's generating it.
So, with this incredibly complex new structure, how do we find what's truly fundamental? You use a powerful tool called a spectral sequence. The best way to think about it is like sifting for gold. You run the entire structure through a series of mathematical filters. At each step, you wash away all the noise, all the instability, until the only thing you have left are the indestructible invariants, the golden nuggets of pure, unchangeable truth about the system.
This brings us to a major milestone. The mathematical foundation has been rigorously tested and proven to be completely solid. The structure is secure, it is stable, and it is internally consistent. This means phase 1 of this whole ambitious project is now officially closed. The skyscraper finally has its bedrock.
But, a secure foundation is really just the beginning. The next step, phase 2, is to start building on top of it. And that means integrating two of the most mind-bending ideas in all of physics: the strange, probabilistic rules of quantum mechanics and the super controversial role of an observer in shaping reality. These were left out of phase 1 for a good reason. You've got to let the concrete set before you start building the rest of the tower.
And this leaves us with this one truly tantalizing question. For maybe the first time ever, we might have a mathematical framework that is provably indestructible. So what in the world happens when you introduce the weird, unpredictable world of quantum mechanics onto it? Could a stable foundation like this finally be the key that helps us make sense of the universe's deepest mysteries? That, right there, is the next great challenge.